There's nothing like the view of a quiet river flowing through a small town or a city, or the bubbling sound of water flowing over rocks. Water. We depend on it for drinking. We also depend on it for fishing, swimming, and boating. Industries depend on it for producing goods that we need to live our lives. Some of us depend on it for fishing, boating, and swimming. Most of Iowa is fortunate for their large supply of cool, clean water. Take a closer look, and we find the water we depend on for so many things, in some cases, is polluted. Only with monitoring and testing do we actually begin to really know our water and find that this precious resource that we depend on for so many things has a dirty little secret: pollution. Most creeks, streams, and rivers that are polluted may at times look normal or clear. Water pollution is not typical of any other type of pollution, as some pollutants can be dissolved into the water. You can't really see it or taste it, which makes it difficult to believe that there really is a problem. But it's there, and your local stream or creek is talking to us, if we would only listen. We need to listen and improve how we manage our water to improve and protect this precious resource, water, for generations to come. Each of us lives in and directly affects a specific body of water. That is called our watershed, and it has a specific address. In Iowa, that point would be either your local creek, streams, or if you live on a river or lake, directly to the river or lake or even a wetland. Watersheds come in different sizes. The largest watershed in the Midwest is the Mississippi River Basin. In Iowa, all water eventually drains to the Mississippi or Missouri rivers. Tracing how the water gets to these rivers can get as precise as water draining off a farm field or a city parking lot. Most of our streams in Iowa are in rural areas that are influenced by agricultural land practices. The majority of Iowans live in cities where watersheds are influenced by city life. Take a look at an Iowa county in 1840. The landscape was covered by tallgrass prairie, oak tree forests, and a number of wetlands. When it rained back then, water slowly moved through the soil, percolating down to recharge groundwater or replenish the stream with cool, clear water.
So historically then, the receiving waters would have been fed primarily by this constant cool discharge of groundwater, which of course was clean water as well, and the surface runoff, which today is the mechanism that moves pollutants off of our landscapes into our surface waters, would have rarely impacted the surface waters. So if we move into from the historic hydrology and start looking at our modern runoff-driven hydrology, it becomes quite apparent why we have some water quality problems. When we have managed stormwater in the past, it's been primarily for flood control, and we've accomplished this primarily through the installation of detention basins, which, to simplify things, are essentially holes in the ground that are designed to take runoff from the very big storm, temporarily hold it, control the rate we release the outflow so that we don't create out-of-bank flooding downstream. So where surface runoff moves across our landscapes, and in particular our urban landscapes, which feature parking lots and roofs and roads and other impervious surfaces that prevent rainwater from soaking into the ground. Now we have this mechanism for picking up sediment, picking up hydrocarbons that have dripped off of a car, picking up heavy metals from brake dust, picking up bacteria, whatever pollutant load, picking up litter, floatable litter. All of these pollutants move in surface runoff, enter a storm sewer, and move directly to a receiving water.
Some of these pollutants we can see. Take a closer look at your local streams after a rainfall, and you will usually see brown-colored water, or water that looks like chocolate milk. That brown color is sediment in the water. Other pollutants we can't see directly in the water, but we can see their effects on the aquatic life in our streams. Excess nutrients from fertilizers cause blooms of small plants called algae that can deplete oxygen needed for desirable fish, plants, and other aquatic life. Some bacteria that are found in water from runoff from animal waste feedlots or improperly operating septic systems can be harmful to humans. Are you beginning to wonder what you can do to help prevent pollution and improve water quality in our streams and lakes? First of all, be aware that there are now federal, state, and local stormwater regulations to help protect and improve water quality. The community in which you live may be required to implement certain programs that prevent pollution of stormwater, or it may simply want to improve water quality for the sake of improving the quality of life in your community. So what else can you do? Contact your local stormwater manager to find out if there are volunteer opportunities. One such opportunity would be adopting the local stream in your neighborhood. Another may be attending a local stormwater management workshop. Another yet is joining in a local watershed group. If one doesn't exist, why not start one? More ideas for how you can help improve water quality are found at www.iowastormwater.org, your statewide connection to stormwater issues in Iowa, your city's website, or IDNR's website at www.iowadnr.gov.